Hello and welcome to Algebra Unit 4-2. This is Lesson 4. So today's objective is scholars will use cube root functions to model situations and evaluate rate of change in cube root functions. So we're going to be modeling and then evaluating our rates of change. So, Creative Clays is increasing the package size for its art clay. The designers are considering different sizes. Assume that the new package will be a cube with a volume of X cubic inches. For what increases in volume would the increase in the side length of the packaging remain between 1 inch and 2 inches? So we can see that right now our original clay cube contains 8 cubic inches of clay. So we get using the function f of x equals the cube root. So remember, the sides of a cube are the cube root. So, just so real quick, the original side lengths of our cube root of 8 would give us 2. So right now they're 2 by 2 by 2 cubes. So we're going to use this, the cube root of x minus 8, because this is the change. We want to know what the new size is. So we're looking at how much it would change. We want the f of x to be between 1 and 2. So we can go ahead and put this in a graph. If we put this in a graph, we can see, obviously, when x is 0, our volume was 8. We can see that at an x value of 1, our volume is 9. At an x value of 2, our volume is 16. So for the change in the packaging to be between 1 and 2 inches, the volume of the amount contained would either be 9 to 16. Would be the change. So that would be the increase in volume if they increased it by 1 to 2 inches. So basically, if it went from 2 inches cubed to 3 inches cubed, we would have an increase of 9, because we would go from a volume up to 9. So, let's look at this one. For the function f of x equals the cube root of x minus 1, how does the average rate of change from x equals 1 to x equals 5 compare to the average rate of change between x equals 5 and x equals 9? So we're actually going to be finding the values and doing this. So I need to find the value of f of 1. So f of 1 is the cube root of x minus 1. If f is 1, I put that in there. That gives me the cube root of 1 minus 1, which is simply 0. So f of 1 equals 0. Now let's find f of 5. So if I have 5 as my input, but the cube root of 5 minus 1 is the cube root of 4, which if I put that into my calculator, because that is really the easiest way to find these, you are not expected to know these. I know that it's definitely going to be between 1 and 2, but to find the cube root of 4, that gives me, I'm going to round this to, say 3 decimal places. I have 1.587. And then the next one I need to find is, I need to figure out what f of 9 is. So f of 9 is the cube root of 9 minus 1, which is the cube root of 8, which I know is 2. So now I have the values of each of these. Now I need to find the average rate of change. So the average rate of change from 1 to 5, my output, the difference in my output is 1.587 minus 0 over 5 minus 1, Ooh, that's ugly. 5 minus 1. So I have 1.587 divided by 4, which gives me 0.397. So that is between 1 and 5. And then yellow. So then if I want to go between 5 and 9, I'm going to do 2 minus 1.587 over 9 minus 5. So 2 minus 1.587 is going to give me 0.413 over 4, which gives me 0.103. So as you can see, the change between 1 and 5 is definitely greater than the change. 1 and 5 is greater. But we actually found those rates of change. Well, let's look at this last one. Now we have a graph and a table. And the graph and table both represent translations of the cube root function. So the values in the table are rounded to the nearest hundredth, that's 2 decimal places. Which function has a greater average rate of change over the interval 2 to 4? Well, for my table over here, it's very easy. I've got my values right here. So I'm going to do 2.81 minus 2.48 over 4 minus 2. And again, I'm putting this into my calculator. So there's nothing bad, so I'm going to do 2.81 minus 2.48 divided by 2. So give me 0.165. Now when I come over to here, I need to find this value right here between 2 and 4. So I do know these values here. I know that it's moved over by 2. It should simply moved left 2. I can tell that. So this is the graph of f of x equals the cube root of x plus 2. So in this case, I'm actually just going to put the 2 in. So I have the cube root of 4 minus the cube root of, I put 4 in there, it becomes 6, all divided by 2. Negative 2, actually, in this case, because I'm going the wrong direction. It would be 4 minus 2. Or 2 minus 4? Yeah, 2 minus 4. Okay, so cube root of 4 minus the cube root of 6. So that gives me approximately negative 0.230 over negative 2. So that I'm going to, when I divide that, it gives you a positive number. So I end up with 1.11. So 0.11 is my answer. Or 0.12, depending on when I round it. 0.12. So obviously, this part has a greater rate of change. So h of x has a greater rate of change. That's all we're doing is finding the rate of change. Okay, good luck with your work, and I will see you all in class. Bye-bye.